Okay, first speaker this morning is Mr. Pete Parsons. Mr. Parsons holds a bachelor's of science degree in atmospheric sciences from Oregon State University, and was a television weathercaster in Eugene, Oregon, and Portland from 1986 to 2007. He is currently the smoke management forecaster at the Oregon Department of Forestry in Salem. Pete started presenting his weather forecast at this very conference back in 1995. This will be his 16th appearance, and his seasonal climate forecast is available year-round and updated monthly via the Oregon Department of Agriculture's website. Pete also has held several executive council positions with the Oregon chapter of the AMS over the years. Ladies and gentlemen, please welcome Mr. Pete Parsons.
Forgot the mic. This is really, I got to get on both of them here. Okay, welcome, and hopefully this will be something that we'll see you at in future years, and you'll get a chance to really enjoy it. It's a conference that's expanded over the years. It started off with just about a dozen people, I think, in the Customs House downtown, at the Weather Service office in Portland. And then we really need to thank OMSI, Jim Todd and OMSI, for providing this venue, and that's really what, along with some other things, helped us expand. But this is just a great location, and especially being a science-related topic. So I hope you enjoy the presentation, which this year has an afternoon session, which it didn't before. I've been doing this again since the mid-90s, and I've made some changes over the years in the way that I've done things. Some of the things have stayed the same, but I've changed. I used to do a forecast specifically for Portland, and then I realized that, well, perhaps it's not as accurate to try to pinpoint down a specific spot, so I went to zonal averages across the state, which you'll see. And I used to do month-by-month forecasts, but months are kind of arbitrary where they cut off, and it makes it kind of difficult. You can actually have a pretty good forecast, but if you go month-by-month, it doesn't look real good. And so then now I tend to do in 3-month blocks, because you can really pick up trends that way. But regardless of the changes that I've made, I still cannot do as well as the experts right here. And that said, let's open this up for today's reading. If you brought along your almanac, let's turn to page 200. If you don't have one with you, just go ahead and look on with somebody next to you. Page 200 at the top, it talks about how we predict the weather, and you can go ahead and purchase one if you don't have one and take a look at that. And they're at a check stand everywhere right now. And also, then later on down further on that page, it says, how accurate was our forecast from last winter? And it says this and that and so forth. But then at the very bottom, it says, thus, our winter precipitation and temperature forecast was 90.6% accurate. Quote. I can't beat that. What happened to my presentation? Yeah, there we go. I can't beat that, but I aspire to someday be as good as the experts here at the Old Farmer's Almanac. So let's bounce along here. PWODT stands for each way of doing things. George Taylor coined that phrase about 15 years ago when we started doing this, because we know what OMSI stands for. The website's down there, and if you didn't jot that down, no big deal. All you have to do, this is housed, I update this forecast monthly. I've been doing it for several years now. It's on the Oregon Department of Agriculture's website, and so again, the forecast updates every month. I'm always looking at the analogs and changing them and so forth. So if you didn't jot down the website, just Google Oregon Department of Forest or Oregon Department of Agriculture, and this is their homepage. And then down here in the lower right corner, there's a weather link, and it gives you this page. And lo and behold, within about 15 seconds, you'll get to the forecast. It's in both PowerPoint and PDF format. And you might say, why? Well, a lot of people, for some reason, even though this has the nice animations in it, which you'll see, they like the PDF. That was actually downloaded last year. It's up to over 30,000 times. So that's the #1 downloaded product on the Oregon Department of Agriculture website. And right here is my forecasting methods in more detail than I'm going to describe today. And then here's the verification of the climate forecast from the previous month. I always put that up there. So how many of you were here last year and saw my weather forecast up here? Yeah. All right, so you might know that I had my best prediction since I started doing this back in 1996. And in fact, it is the only prediction that I have ever had that beat the Farmer's Almanac. I was 100% correct. Can any of you remember what it was? But I was 100% correct on it.
Packers win Super Bowl.
That's right. I said it this, that's the graphic I use. Packers will overcome injuries and win the Super Bowl, and here's the verification right there. Oh, that's nice. I'd like to just look at that for a little bit. For those of you who don't know, that's Clay Matthews and Aaron Rodgers are the two best players in the league and the best team. Now, back to the weather. Here's my verification from last year. Again, this is for November through January. My forecast precipitation was for above average precipitation, especially west of the Cascades. And because we got that big ridge over us, which was unexpected, very untypical of La Nina, it was actually not as wet as forecast. Not bad, but not as wet as forecast. Temperatures, I said we're going to be around average, maybe a little warmer, east of the Cascades especially, and that wasn't too bad. This may look more dramatic than it is, but keep in mind, if you see the scale down here at the bottom, those are only 0.5 degree Fahrenheit graduations for zones, so even though it shows up here as orange, that's only 0.5 degree above normal for the whole zone, so it's not that far from normal, so that wasn't too bad of a forecast. Not 90.6%, but not bad. Precipitation forecast for the second half of the winter, I went for quite wet west side and closer to normal, but still above average east of the Cascades. And it was not as wet as forecast, again, for reasons that Mark discussed with the Big Ridge. It turned out to be wet just after this period ended, but again, missed it right in that block. Temperature forecast for the last 3 months, December through February, that's probably my best forecast for a 3-month period on any time. That's about as good as you can do. Again, not as good as you can, but pretty good. Now, the winter forecast, in general, I said well above normal precipitation. I'll code that as a miss because we were more near normal. Near normal temperatures was right. Above average snow did eventually happen. It was late February into March when it happened, though. And I said we'd get one or more of the following. We actually had 3 Arctic outbreaks that I remember, but they didn't have a lot of snow with them, which is typical of going into a La Nina, especially the first year of La Nina, but not necessarily the next one. More on that in a minute. Now I want to spend just a minute, and is there anybody here that hasn't heard about El Nino or La Nina ever, anything about it? The media covers that quite a bit now, so that's good, so people are more knowledgeable on it. I'm going to cover a little bit of this now so that speakers that come up after me don't have to. And El Nino and La Nina has been going on for long as we know and beyond, but it really came to awareness for myself and a lot of folks in the meteorological community back in the early 80s when we had a massive El Nino in 1982-83, and I was at Oregon State at the time, and the professors were buzzing around, this is really a cool thing. And what we noticed is that there was no question that it altered the weather patterns globally. And to give you an idea, these are examples of classic strong El Nino on the left side and La Nina on the right side. And when we talk about those, we're referring to the temperatures on the tropical Pacific Ocean. That's the tropical Pacific, these are the Americas, and over here Australia. And this is the equator. And notice the tropics, that the pattern is different in the tropical Pacific Ocean temperatures. These are in degrees centigrade. And with an El Nino, the warm water spans across the entire equatorial Pacific. With La Nina, due to stronger trade winds or easterly trade winds along the equator, the water is held bottled up in the western Pacific. And that essentially is the difference between El Nino and La Nina. Down on the bottom panels are the departures from normal. So red down here means above normal in degrees centigrade. Blue is below normal. So you have above normal temperatures in the central and eastern Pacific because that water's been allowed to slosh back due to weakening of trade winds. Here with the stronger than normal trade winds, you get some upwelling and things are cooler over here. All the warm water is bottled up over here. Okay, that's all well and fine, but because this area is so large and the ocean, sea surface holds so much heat, a slight change in temperature of the sea surface ocean drastically changes the heat budget around the globe, and we know that it has a pronounced effect on the weather patterns. And here is a general look at how it affects the weather patterns. In an El Nino or warm event, The subtropical jet stream is strengthened all the way across the Pacific. You've got those warm waters down there supporting that. And the polar jet stream is redirected up with southerly flow into Alaska, and then the cold pools of air are driven way into the northeast U.S. and even points further east, and typically leaves the country pretty mild. In the Pacific Northwest, because of this split in the jet pattern we talk about, the Pacific Northwest warmer and drier than normal, and in the southern tier states get wet because of that subtropical jet. And the meteorologists and weather geeks on the East Coast salivate when they see El Nino, because look at the way the polar jet wants to come down and collide with that subtropical jet, and they can get some blizzards in the Northeast, so they get all excited about El Nino. Over here, it's more boring, really. We just get kind of mild winters, but if you like mild winters, that's what you want. La Nina, on the other hand, which is what we had last year, the polar jet, or the subtropical jet, is weakened, indicated here by not being as thick. These graphics are courtesy NOAA. That allows the polar ridge to form farther west, and the Arctic dumps are more inclined to come into the United States. I'm not thrilled with this graphic. I think actually this depicts more of a neutral condition than it does a La Nina. With neutral, you have a strong enough subtropical jet to throw moisture over the top of the Arctic dumps. And in fact, our biggest snowstorms here, if you look back through the records, occur within so neutral. With La Nina, this is really weak like it was last year, and you can get big dumps of cold air, but a lot of times instead of coming down here, they'll drop down into the Pacific Ocean like they did a lot last year. You saw the maps that Mark showed, and you get a big trough that carves out right here, and we get a ton of mountain snow and valley rain, and not necessarily a lot of valley snow. And when we do get cold air that dumps down into the valley, there's no subtropical jet to throw moisture over the top to give us snow. And we tend to get out of it with just southwest flow and then maybe a brief transition. And that's what happened last winter. So my method of doing forecasting is I look at indices, which I'll go over briefly here, and they're in more detail on the website, indices to identify years and sequences, not just a current year, but an evolution of years with similar tropical Pacific Ocean temperatures to the current year. And then I use weather data from those years to look forward in the future. And it's called analog forecasting. And it's really about the most accurate thing we have for forecasting at this time range. In the short term, the Weather Service has dynamic computer models that use mathematical equations to simulate the atmosphere. Much more accurate in the short term than this is. This just gives general ideas. That's why when you take this forecast and you try to narrow it down to a point, it becomes almost worthless because it's not accurate enough originally to be able to make it more precise. And it took me a few years to realize that. But I do not correct for changes in global climate, which there are. If I have analog years that are, say, back in the 1940s, and then I want to use what happened those years to predict what's going to happen this year, there's been some climate change between then and now. I don't correct for that because I wouldn't know how. And I know that creates error, but I'll live with that error because this method is still better than just forecasting average conditions. Now let's talk a little bit about the SOI. The SOI is a Southern Oscillation Index, and the reason it's so good to use is because it's simple and accurate. All it is a pressure reading. It's a pressure reading at Tahiti in the Pacific and Darwin. You take the monthly average of those two, and then you subtract Darwin from Tahiti, the anomaly of you subtract the departures from normal from each other. So it's the departure from normal at Tahiti, in this case it's negative, and then you subtract from that the departure from normal at Darwin, in that case it would be positive, so you have a negative minus a positive, so this would be a negative Southern Oscillation Index, which, what does that mean? That means that you have weaker than normal trade winds, because we know that wind blows from high pressure to low pressure, so if you drop the pressures here, the wind normally flows this way from east to west, the trades. If you drop the pressure here, it's going to relax that wind. These color schemes are pressure anomalies, that's not temperature, so don't be confused by that. In this case, you'd have weaker than normal trade winds, that allows the warm water to slosh back. Over here with La Nina, pressures are higher in Tahiti than normal, lower in Darwin, stronger than normal trade winds keeps the warm water bottled up over here in the Western Pacific. So a negative Southern Oscillation Index is indicative of El Nino or warmer oceans, and La Nina is a positive SOI and it's colder. Here's a graph courtesy of Australian government of the SOI index over about the past 5 years. And note the La Nina is the positive ones, and El Nino has periods of negative. So this is a weakening of the trade winds, and these are strengthening of the trade winds. You might look at that, okay, up, down, I don't see what's going on with that. But alas, patterns emerge, and here's what I look for. Notice here in 2006, 7, 8, we went El Nino, La Nina, back toward neutral, then into La Nina. Now look what we just did. El Nino to last winter La Nina, back to neutral, La Nina. That is a very close match. And that's what I look for when I'm looking for analog years to base the forecast off of. So in this particular sequence, we're right here in the sequence, which would be right here in this sequence, which would be the fall of 2008. And that's why because it's so close to now, that to me is our best analog year is 2008. Well, what happened in 2008? ONI is a measure, it's a little more complicated, but it's a measure of the actual temperatures in the Nino 3.4 region. This is the region that the National Weather Service bases their definition of El Nino and La Nina on. And it's the departure from normal throughout this whole region, and that's from 120 west to 170 west, 5 degrees north and south of the equator. Here's the equator, is the Americas. And that's the region that typically would warm up in an El Nino and cool off during the La Nina event. Their definition is quite strict. That region has to be, they take a 3-month overlapping period on the anomaly, and that has to be plus or minus 0.5 degrees centigrade, plus would be an El Nino, negative or cooler than normal would be a La Nina, and then it has to hold that for 5 consecutive periods, 3-month periods, in order to be a full-fledged event. Very restrictive. I would say you have some shorter term, shorter scale La Nina and El Nino events that don't meet that criteria because they don't last long enough, but they get away with that by saying we have La Nina conditions but not a full-fledged event because it didn't last long enough, and I'll go into detail on that in just a second. Here's the Nino 3.4 index from the Australia government for the last 6 years, and notice it's the opposite of the SOI. When SOI is positive, ONI, or the temperatures in that ocean area, become negative. So here the El Nino events are positive, the La Nina events are negative. Notice how I'm coining the 2008 here as a La Nina event. Technically that wasn't by the Weather Service, but it sure looks a lot like a La Nina event. It was just short-lived. It missed their criteria by 1 month. It was cold enough. It was actually, it fell right down to -1 is considered about the moderate La Nina. It actually made it all the way to about moderate La Nina. It just didn't stay there quite long enough. But by that time, we'd already had our snowstorms by the time it wanted to warm back up. Again, a pattern emerges. El Nino, La Nina, back to neutral, La Nina. El Nino, La Nina, back to neutral. I mean, that's almost perfect. That's about as good as a match as you can get. That would put us again back in 2008. Here's another way to look at it. Here's 2 winters ago. This is an El Nino Modoki from 2 winters ago. There's the anomaly warm in that Nino 3.4 region. Here it goes. In February of last year, we went into a La Nina. And then now we went to INSO neutral briefly in the middle of summer. And then here's the evolution since then. And notice how it's cooling off. And here we are into La Nina conditions. This is not a full-fledged La Nina event yet, it hasn't lasted long enough, but notice how it's cooled off again across the equator. And here's how it compares to October 2008, that's my analog. Again, it wasn't as cold in 2008 yet, but look how quickly it got there. Here's December 2008. That doesn't look very neutral to me. That's weak to moderate La Nina, and that's right when we were having our snowstorms here. So here we are now, not that different, again, from 2008 in December. So we're in the ballpark. So my forecast for this year, 2008's one analog. There were 4 other years that I found going back, so a total of 5 that went El Nino, La Nina, and then to either a neutral or another La Nina. The second La Nina, back-to-back La Ninas, is usually a little drier than the first year and a much better chance of valley snow, as we saw back in 2008. November to January, precipitation a little bit above normal, I think. Temperatures are probably going to be a little bit on the mild side overall, but that doesn't mean we're not going to have cold spells. Probably will. Probably oscillate back and forth between cold and mild, but the overall average may not be that far off from normal. December to February, Precipitation, again, above normal, especially west. Temperatures probably not that, a little below average west, a little above average east, but there can be some Arctic outbreaks in there. So the winter forecast, above average temperatures early. If skiing opens by Thanksgiving, that's a plus, but I would expect a good ski season this year with above average snowfall that'll last well into the spring like last year. The cold periods have a better chance of snow in the valley. Most mountain snowpack should be above normal by the end of the year. So if you're interested in snow, I do something called the snow lights. Average Portland snowfall is 4.5 inches. Average of my analogs is 7.5. So I think we're likely to see above average snow in the Willamette Valley. And watch out for freezing rain. We don't mention that a lot. But remember 2008, we had a layer of ice between all that snow too. So that could happen as well. The big question though is, could we see a repeat of 2008, 2009? You know, where we had 2+ feet of snow? Or worse. Could it be? Could it be? Yeah, I've shown this graphic for, I know a lot of you have been here a while, I've shown this graphic every year since I embarrassingly bought this back in September of 2000. So that's it. I'll take a couple of questions because I won't be here for the panel because I have to get back, this is my work day. So if you have any questions for me.
And actually, really quick, Pete went kind of long, so we can take about 2 or 3 questions, and then we got to fly.
Yeah, just if they're specific to me, otherwise you can ask the panel later. Yeah.
I mean, well, like, hey, I actually have a question though. Well, like, I mean, though, like, hey, when we had like, hey, the freezing rain and the snow and stuff though, like, hey, do you think that this year we are going to see like a very similar thing though, like we first start out with the dry, the dry snow, and then it gets wetter, and then it, you know, ices up and stuff though. Like, are we going to see the same thing this year that we did in 2008 or not?
Well, I think it's difficult to get real specific. I would just say that the chances of getting valley snow this year are above average, but there's no guarantee. Of the analog years that I have, I think there was one of them that didn't have any snow, so there's no guarantees. And then one of them had the big snow, another one had a moderate amount. So, but the overall chances I think are elevated this winter, but I can't get real specific on what it'll look like. And the other thing about La Nina is, well, the window's open from mid-November all the way to mid-February with La Nina. You can get that anywhere in there. The best chance is usually December, January, climatologically.
Gary?
Right here. I just wondered, do you ever see I'm right here in the front, Pete. Right
okay.
Do you ever see what I would call a La Nina lag, in that it's kind of past neutral and starting to warm up in the tropics, but here in the Northwest it still feels like La Nina in January, February, March, April, May, June, all through summer, I mean up till September. It felt to me like it's still La Nina.
Well, it's a great question, and it's, you know, the atmosphere, and this is part of my theory for looking back 2 or 3 winters, and I don't just like to look at it what it's doing right now, but if you look back through the records, the evolution's important because the atmosphere has memory. There's momentum. So yes, you do get a leg, and in fact, even though we went to neutral conditions briefly this summer, reading the discussions from the National Center of Environmental Predictions, we never really lost the La Nina characteristics of the global atmospheric circulation. And now we're going back into it. So yes, there is memory in the atmosphere, momentum, and I think it carries beyond just the short term. I think there's memory for 2 or 3 years back, and the climatological records would support that because, again, a La Nina coming out of an El Nino is usually real wet, like we had last winter. The second one usually isn't as wet, and the third one sometimes can give you a real dry winter. So there's definite signals if you look back that way.
I hate to do this, but we have to wrap right there.
Okay.
Thank you. Sorry, like I say, I know Pete's got to go, and we're actually now about full 15 to 20 minutes back, so we're going to fly here real quick. Ladies and gentlemen, Pete Parsons, everybody.